Well, good evening everybody. Welcome back to my channel. If you're new to the channel, thanks for coming by. Consider liking and subscribing. Got lots of good information out here. If you're returning, I appreciate everybody that stopped by and visited, and thank you so much for the subscribers. That means a bunch to me. It means I've got something that's worth somebody's interest. Anyway, where we left off on the donor the last time, we determined that I don't have any communication in between the diagnostic link connector and the ECM. So we're going to address that. We've got to do some wire testing and find out what's going on there. A couple things we've got to get cleaned up. I'm going to look at if we can save any of this stuff. I don't think any of it's salvageable, to be honest with you. I know that the bumper bar is bent, so it's not going to be salvageable. I think the fascia is it's beyond repair. It's got a rip down here, but there's some, like the headlight buckets in there and that little stuff, you're going to want to hang on to. Now the header panel that holds all that stuff is going to be trash, so you can pitch that. But yeah, the headlight retainers that goes in the pocket, those you're probably going to want to keep. Little stuff like that that may not always be available. But the crash bumper there, the black piece, half part of it's missing, so it's really no good either. So that whole thing needs to just be thrown away. This baffle here, the baffle looks like it might be something we need to hang on to, so we'll take that off and save that. Other than that, we still got to get the starter off this thing, but we got to get some access to that door so we can get it open to get to the ECM. So I got to move Charlie, and Charlie doesn't run yet. I haven't had a chance to fix it yet. It may not be something you want to, or leave me a comment below if you want to see any repairs on it, and I'll tell you what we got to do. It's got a fuel pump that's locked up in it. I'm sure it's because it's sat for too long, and the ethanol is murder on stuff if it sits for any kind of period of time. Even the E10, which is what you get at the pump, it's murder on stuff. It corrodes stuff. It's not good deal. Anyway, I got to put a fuel pump in that. It also has a right front hub bearing that's bad, and it needs a couple sway bar links, just some basic stuff, and it should get to where it can run. It does have a transmission leak. I had a guy that I thought was going to do me a favor up north before I came down here because I didn't have time to jack with it. Fix an issue with the transmission, and in the same instance he fixed the issue with the transmission. Now it leaks out of the transmission torque reverter seal. So I'm going to have to pull the transmission back out of it, but I'll probably do that up at the shop. It's a little bit easier to do it that way. But anyway, so we're going to get Charlie moved, and we'll go from there. So hang tight. Okay, so we got Charlie pushed out of the way, and we got a clear opening to the door. So that's, well, I got to go from the inside and get the door open because the door handle seems to be broken. So hopefully I can get it open from the inside. We'll get started on this. Okay, y'all, I'm going to switch cameras because I think this other one may work a little better. I've never tried this camera, so I hope the quality comes out good. We'll try it and see how it goes. This camera does not have a dead cat on it, so you might get a little wind noise, but I figured being in the car you may not hear it. So let's get going on this. We'll get this ECM out. Okay, well, that's probably about the best you're going to get from what it is, but we need to take this hush panel out because the ECM should be right behind this. Alright, let's pull this A-pillar trim off right here. So screw right down here on the bottom. That sounds like it broke. Would not be surprised. Pull the sill plate off the door, and of course the sill plate's broke. Everything's so crusty. Everything's already broke anyway, so there we go. Almost looks like this thing used to have a Bose, maybe had a Bose speaker in it at one time. Because that's what that actually looks like, is a speaker housing. Interesting. Alright, well, we just got some 7mm heads on this hush panel. Okay, stand corrected, they're 9/32. I was wondering if they'd be metric on this old. Been so long since I worked on one of these old girls. Had a critter in there. Get that out of the way. Alright, right here in this mess of wires, which you can't see, is the ECM. So it looks like there's just one more screw right there, and we'll be able to pull it down. And there it is. All right. And we have a computer 1227-165, which is pretty common for back then. All right, so for what we're going to want to do, let's go ahead and pull these two connectors out. There's one, two. We'll get that out of the way for the time being. Okay, you have two connectors. You have a 24 pin and you have a 32 pin, which is terminal A and B. Well, they actually go by rails, A, B, and then C and D. So we're checking this diagnostic link connector up here, this here. Okay, so in that picture you don't have anything that's relative to what we want to check. So let's go to the next one. No DLC in that one. Okay, here we go. Okay, you've got your A and B right here. You've got your diagnostic test terminal, which is terminal B, and terminal A is a ground. So the first thing we got to do is let's check the ground. Terminal A12 is right there. Here's your A connector. So go down to the 12th connector. Since this is a 24, it's going to be all the way at the bottom. Now, to tell you which way you're looking at, you look at the picture on either side, and it will tell you basically which way to look at the connector. So, with that being said, if you notice the two connectors are two different sizes. That's your 24 and that's your 32. So we're dealing with the 24, so let's just grab this one. And if you look at the picture again, if you look at the way the connector is, there on the left is what you're going to be looking at for which way to orient the connector. So if you look at the connector, they're showing the tab to be on the left side. So you're going to test with the connector like that. To verify the wire color that you're looking at, if you look at that, it says black with a white stripe. Okay, so just look at your back of your connector. Okay, this is the one time it's going to make a liar out of me. This terminal is flipped upside down according to the picture. Because to verify that you're going to test the right wire, it's going to be the black with a white stripe. And that is right there. That wire right there is your black with your white. So, we need to get the fluke out and test the resistance of that wire to a good ground. Now usually there's going to be a ground right in here. That's an aftermarket speaker wire. Or if you can find anything metal on this body right here, sometimes they put it down underneath the carpet. Man, this thing is rusty. Holy cow. Got a Fred Flintstone mobile going on here. I just pulled this connector out and got some pretty hefty wires in it. So anytime you're doing a test like this, you're going to want to zero out your scale of your fluke. So the way you do that, you just take and touch the two terminals together. And if you notice, it'll give you a reading. That's the resistance of the wires and the meter itself. Now they've got a little relative triangle button that's right here. If you push that button, it'll zero the meter. There you go. Alright, so now we know that that's going to be relative. Probe your black with the white stripe, which we determined is this one right here. And you don't want to use a big bulky terminal to get in there, because what will happen is you'll spread the terminal apart and then it won't make a good connection. So I got a little small wire in there. Now, we got that there, and we're going to test on terminal A. Terminal A is the ground. Terminal A is going to be the one all the way on the right. So let me go around the other side so you guys can see it. Okay, terminal A should be that one right there. And there you go. You got 0.9 ohms of resistance, which is well within specification for a ground. So we know that the ground wire is good in between the ECM and the ALDL. So while you're over here, test the B. Okay, it still shows out of limits, which means there's no resistance, there's no connection. So we know terminal A is good. So now we need to test the other terminal, which is terminal B. So that says it's A9, which is on the same bank of wires that we're at, but it's different. It's white with a black tracer instead of black with a white tracer. So if you look in this harness, and there you can see it right there, this wire right here, that's your white with a black tracer. So that's the third wire in, fourth wire. So just count down your holes. You got 12, 11, 10, 9. Should be that one right there. So you put that in there, and we'll go around and test the other side, see if it got continuity there. So we're going to touch terminal B. And that's actually no resistance. There's a possibility that because it's showing negative, that means that wire is definitely good. All right, so we know that we've got a problem there. So what I did is I went ahead and plugged the ECM, or put the power on anyway. And we're going to check our powers. Let's find a good ground for this lead, which looks like it's probably going to be, let's see if there's one in the tunnel we can grab. Let's try that right there. So let's check our powers and grounds. Better yet, let's see if we can get some, so the key's on. So they've got it going. Let's see. Okay, let's turn that back off. Let's check the grounds, which on this one we've got, so we're going to check, which we already did once, but let's check it again. A12, which is a ground. Okay, it's got 0.6 ohms, and we got terminal D, D10 and D3, which if you grab your other connector, look at the back here, and that should all still be the same color, black with a white stripe. There it is right there. So count down from the top here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, D10 is supposed to be a ground, and it doesn't look like it is. Okay, these are numbered on the back. You guys aren't going to be able to see this here, but when you're looking at them, if you look at the back of these on the, get that out of the way, right here, these things are numbered. They're real small, but you can see them. So we're going to check D3, which is actually at the bottom. So that one should be a ground, and it is. And we've got 10. So count from the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That should be a ground. And it is. Alright, so got grounds there. Let's see if there's any other grounds on another page. Okay, no grounds on more on that page. Let's go to the other side. Okay, back to the A terminal. A12 was an ECM ground, which that's the one we already checked, I do believe. Should be that one there. And it is. We get another one, we already checked D3. And D1 says it's a ground also. And it's also black with a white stripe. And that one's a ground. So all our grounds are similar. I mean, we all got the same resistance on it, 0.6 ohms. That's within reason. So at that point, let's check for voltages. We need to check for battery positive voltage. And that's going to be at B1 and C16. So again, B is on this side. It's B1, and we're going to do C16, which will be all the way at one end. It's an orange wire. So let's check to make sure it's got battery positive to both of those. Okay, there's your orange wire, B1 right there. Okay, we got battery voltage. Got 1258. So we got good one there. Let's check this other one, which was C16, which it'll be at the end of a terminal 2. And there it is right there. That orange wire right there. So let's check that one. And we're good there. Make sure there's no more voltages. Because there should be a switched voltage too. That comes into effect, and there is. Okay, on this one here, here's your ignition feed circuit. So it's pink with a black tracer. It's terminal A6. So let's check. Okay, there it is right there. I don't know if you can see it or not, but it's pink with a black tracer. So let's check that one. 1, 2, 3, 4, 5, 6. That one there. Okay, let's turn the key on. And we've got voltage there. Got a little bit of a voltage drop. It doesn't quite have battery voltage, but you know, it's going through a lot of stuff too. Well, let's make sure that it doesn't have more than one ignition feed circuit. Sometimes there's only one, sometimes they use more than one. And from what I see, that seems to be the only one that turns the ECM on. Yep, that's what it looks like. Okay, so now we're at the point, let's turn the key off. Let's plug the ECM back in. And we'll test outputs. That way we can find out whether or not this box is junk or not. Alright, so the first one I think we ought to check. I think I'm going to need my wire splicer to do this one. I should have brought it with me, I think. But we need to check for a 5-volt reference. Let's find a 5-volt reference wire. Okay. Good one to check is for the throttle position sensor. So the throttle position sensor is here. And looks like it's a gray wire, terminal C14, should be a 5-volt reference wire. So we got to find it on this terminal of the 32 terminal connector, and it's going to be just a plain old gray wire. I pulled this connector down, now it's in the way. I wish I could pull more of this wire harness out. Okay, and it's terminal C14, so that looks like it's going to be that wire right there. Yep. Alright, let me go find my wire piercer, because that'll be the easiest way to check these. I'll be right back. Alright, these things here are really awesome for checking electrical. Your test lead goes in there, and that's a wire piercer. It's got a spring-loaded deal. You just open it up far enough you can get over the wire, then you screw this end down, and it pierces the wire, which is great. So we're going to slide this dude over here. And screw it down. And now we've got some place to use for our test lead to go into. So plug that in there, and let's turn the key on, see what we get. Alright, so there you see we got 503. So the ECM is sending out a 5-volt reference, so we know that's what it's supposed to do. Still kind of confused why it doesn't want to talk. Well, that being said, we should be able to see coolant temp sensor, TPS, and manifold absolute temp sensor ground. Okay, we checked D2, so let's try C13 to see if we're getting anything back from the TPS, which that's terminal C13, and it's a dark blue. It looks like it right there. Well, that's interesting. You shouldn't be getting 2.5 volts on a TPS sensor for sure. And the only difference is I've got the ground on the inside of the chassis. So getting a signal back like that is definitely not right. All right, so let's do this. Let's test the manifold air temp sensor. I'll put it back on ohms. Let's see what the resistance to ground is, which the manifold temperature sensor should be C12, which is flat tan wire. So on that same connector right there, there's a tan wire. Let's probe into that dude. Okay, we got 19.91 mega ohms. Seems a little high. 19.91 mega ohms, and it's a thermistor basically. A thermistor is a variable resistor basically. Your coolant temperature sensor should be the same way. So on that one, C10 is a yellow wire, which is on that same connector. So let's see what that one is. And that's that one right there. And that's 5.54 mega ohms. So the good news is the ECM is working. Still kind of confused why we're not getting the thing to communicate. Is if you were to ground the white with the black wire, it should flash the check engine light. So let's grab that terminal A9 again, which is white with a black stripe. That's the smaller of the two terminals. There's your white with a black stripe. So let's pierce that dude. And we'll just grab our ground lead out of our fluke. And it just doesn't do anything. Okay. One last shot here. Let's test this orange wire, which is on A8. No, that's not right. Yeah, it is A8. But we're on the wrong. Yeah, that's the right one. No, it's this one here. That one right there. Alright, that's terminal A8, so let's pierce that one. Put your fluke on voltage, because it should. It's a real low voltage speed, I guess you'd say. Yeah. See, it's showing a voltage of 495. I'm going to have to look up to see what the specifications is, but usually if it's 495, I do believe it's supposed to have less than 5, well, a lot less than 5 volts. It should be more around 1.5 volts, I do believe. And it's not moving at all. Alright, I might have to do some testing. We're going to hold it off for there for tonight. For one, it's darker than all get out. So, and I know you can't see me very well. We're going to end it off there tonight. And I'm going to do some checking on what I found. And that'll tell us if the ECM is dead or not. You know, maybe I'll get lucky and the one that's in Scarlet is the same ECM, which it should be. It should just have a different PROM chip in it. I know Scarlet used to be a tune port when I got the thing from the kid. Of course, it didn't have any drivetrain in it, and the guy had changed it over to carbureted. But it should have the same ECM in it, and a lot of times you can just take the PROM out of it and swap it, and it'll work. It would work for testing purposes more than anything, which is what we really need to do. Because it looks like the wiring is testing out okay. So it's more than likely got a faulty ECM. We know that the old donor will not run without it. So that being said, consider liking and subscribing. I know this one was kind of long and boring, but this is part of what you deal with if you want to try to work on the older stuff. I mean, that's just what it is. Done this for 30 some years, almost 30 years. You get all sorts of stuff, and the new stuff is even worse, especially when it comes to electrical, because there's so much being controlled that way. But anyway, hey, I appreciate you all sticking with me, watching, if you watched to the end anyway. Consider liking and subscribing. With your all's help, I can keep this stuff going to be able to teach you more. Anyway, y'all have a blessed day. Thanks so much for watching, and until next time, we'll see you later.